Okay, so now let's see some more practice questions. Alright, so next question is asking how many quarters are there in a year? How many? 4. And of course, they are only 3 months in a quarter. Okay. Good. Alright. So what's the future value of a loan? Of course, it's 0 because you want to pay your loan off. And next question. Alright.
I'm going to add one extra tip and trick. I just thought about it. When you hit second clear time value of money, it's easy to think that it cleared it and have it actually not clear it. If you didn't quite hit that key right, it's not necessarily going to clear it. So when I'm filling up a problem, I'll always just go ahead and type in 0 for the key that I'm not using, just to confirm that that key really is zeroed out, just to make sure that I didn't forget and not clear my calculator properly.
All right, thank you. So Cliff invested some money at 8% APR compounding quarterly. He left the money accumulated for 30 years and now he has this balance. So what was the initial amount that Cliff invested? So first of all, we have compounded quarterly, all right? So first of all, you need to adjust interest rate and number of years that you have. So 8% divided by 4 is 2 is our interest rate. Also 30 years times 4, 120 is our N. So because we don't have any monthly payments or payments, so PMT is 0, and after 30 years, the future value is going to be 12,918.9 cents. And because he's gonna take out the money and put back into his pocket, so this should be positive. So put the number and then hit future value, and to solve for present value, we need to hit compute and present value. So if you just run the number, Cliff has to invest $1,200 today, and then after 30 years, he will have $12,980.90. Right. Because we don't have time, let's go to the next question. Alright, so work. So your credit card is maxed out at $2,000. You quit using the credit card and make the minimum monthly payment of $50. Assuming your interest rate is 21%, how long will it take you to pay off the balance? All right. So in this case, you need to put 2,000 positive as your present value, and then because you want to pay your credit card, so future value is going to be 0, okay? And then because you are going to pay monthly payments, you need to adjust the given interest rate. So 21 divided by 12 is going to be 1.75. So 1.75
So make sure to plug it in. So on your calculator, do the 21 divided by 12 and then plug that in for I. In this example, it's a nice even number, but in case it's a weird number, always just try to plug it in that way.
Okay. All right, so 2,000 was our, I'm just reiterating the numbers to make sure you have it there. And then 50 is monthly payments out of our pocket, out of your pocket. So negative 50 is the payments, okay? And I think we are good. And then we solve for n. So compute and again make sure you adjust n by dividing it by 12. So you have 5 years and I don't know, yeah, almost 6 years to pay off your credit card.
All right, so if the annual interest rate is 6%, how long will it take you to double your money? I love this problem because it's a little bit different than a lot of the others. There's no dollar amounts here. So can anybody tell me how they would set up this problem? Any ideas? There we go. So when you see a problem like this, the interest rate is the most important component. It honestly doesn't matter what the dollar amounts are, as long as the dollar amounts are double. So, sorry. See, I have to run back. So we're going to enter in 6 is our interest rate. And we know we want to solve for n. So this is why I like to start with the n, start with what I'm solving for. And this problem that makes it nice and easy. So we can enter in any number. I like 100 just because it's a nice round number. I enter in 100 for present value, and that should be a negative 100. And then double of 100 is 200, so that's going to be my future value. I'm going to just plug in 0 for payment just to make sure to clear my calculator, and then compute n. So it's going to take 12 years to double my money. Notice how I said 12 years, because in this example, we have an annual interest rate. So be very, very careful with that. If you have an annual interest rate, there is no fraction for your, you can't have a partial year when they're compounding your interest annually. So what this is saying is once a year, your investment house is going to deposit your interest. So you can't have a partial year. So this is exactly equal to 12 years in this example. So we're about out of time. If you need to leave, you can. But we still have some extra time. We're here for a while. So what I would like to do, if you would like to, we have a whole pile of these practice problems. If someone wants to take a stab at running through them, and then we can just kind of work together to solve them. Anyone interested in doing that? All right. So first person to raise their hand gets to talk. All right, Chris raised his hand. So Chris, why don't you take us through this problem?
Okay, so the first step is to figure out what piece of the puzzle that you're trying to solve for. So the end of the question says, about how long does Lynn have before she can retire? So we know that we're looking for the n. The next step I would do would be to figure out what kind of compounding we're using. So we can see there that it's compounded semi-annually. So right away I know that I'm going to have to adjust the n once I've solved for it. And I'm also going to have to adjust the rate, 6.4%. So my first move would be 6.4 divided by 2. And that'll give me 3.2 for my interest. The second step would be to figure out the present value. So she has a balance already of, she has a balance already of $413,000 and change. So we know that's our present value. But since it's an investment, it needs to be negative because the money isn't available right now. she will not make any more deposits in the account, so we know that there aren't any more payments, so payment will be 0. And lastly, she won't retire until her account has a balance of at least $500,000, so that's going to be our future value, positive $500,000. The last step after plugging all that in, one second, we'll get it all plugged in the calculator for you. Okay, so now the last step is just compute and then in. Okay, so we come up with 6. However, you need to realize that that's 6 semi-annual periods. So really, we would divide that by 2 to arrive at 3 years.
Now, on this problem, I know I said that we always round up. This won't show up on your exam this close. This is close enough to 3 that I would keep it at 3. It's not going to be this close on your exam. Okay, thank you, Chris. So, any volunteers for the next one? First person to raise your hand gets it. Should be on first. 5 points of extra credit for the first person who raises their hand. All right, we can hear you now.
Okay. Have you looked at the question? So the interest rate.
Yep, so the interest rate is 3.8%.
The years would be, oh, I think the topic, okay, 3, the N would be 3.
Okay.
7,000 would be the PV, negative.
Okay, so you said PV?
Yes. Or, no, sorry, payment, PMT.
Okay, so you want to put that in payment. Okay, what's next?
The present value would be 1,000.
Okay, and is that
So
what
then
positive
we
or negative?
type that in the calculator and look for PV, I'm thinking.
Okay, what did you say we're solving for? Sorry, I didn't hear it.
Do what?
What did you want to solve for?
The future value.
You're solving for future value? So look at the end of the problem again real quick.
Okay, I know that's a little confusing.
So it says, how much will she have to save each month to accomplish her goal? So what do you think we're solving for? Correct. So we're solving for payments. This is why I say don't ever trust that you're solving for the remaining variable. Always double check and see what am I trying to solve for. See, this says how much she will save each month. So where would that 7,000 go?
Okay, so that would be the future value because that's what you want.
Awesome. So now which one's negative, the 7,000 or the 1,000?
It would be 7,000 because she currently has. Oh wait.
So she currently has 1,000.
but she can't use that, so that's what's negative.
Yes, perfect. And another way to look at it is she wants to have 7,000. So she wants to be able to take 7,000 and put it in her pocket. So that one has to be positive. All right. So everything else look good? Everyone agree with the rest of the problem? All right, so if we plug that in the calculator, what do we get? Juliet, if you want to.
Yes. Almost done.
It's all right. Those of you online are also welcome to submit your answers as well. Try not to look at each other's answers before you submit yours.
So I got 1,887 negative.
And 89 pennies, right? Okay.
Yes.
So that's what I got on my calculator when I plugged this in. Does anybody see a problem with this number? Let's step back and do our sanity check. You have to divide what by 12? So, right, so we need to adjust for compounding, right? So the problem, it says, how much will she save each month? So if we step back with this problem a little bit, we have a monthly payment. We're going to save that for 3 years. So if we already have, well, let's see, right. If we were to save this $1887.89 monthly, so that would be 12 times a year for 3 years, and we already had an initial $1,000, then we'd have $68,000 in the account. So right there, you know there's a problem, right?
Yeah.
All right, so how do we correct that? It says we have to divide by 12. What do we have to divide by 12? Okay, so divide our interest rate by 12. So again, this comes up with one of those really nasty numbers. So on your calculator, you would want to enter that in as 3.8 divided by 12 equals, and then interest rate. So we still have our 1,000 is negative, present value, 7,000 is positive, future value, and is 3N. Do we do 3 for N? Three times 60. There we go. 3 times 12, we get 36, so that is our N. And now if we solve for, oh, hold on, there it is. So now if we solve for payment, we get negative 154. It was this, negative 154, that's 44. And this rounds to 44, not 45. So, does that process make sense? Juliet, you did a great job. I'm really glad you pointed out. Those are some of the most common mistakes. That's why we wanted to have this. We always have to stop and think about compounding. But then if you step back and do a sanity check, you can usually realize that you made a mistake. So perfect job, Juliet. Thank you so much.
Thank you.
All right, does anybody else want to take a stab at running through a problem? We still have quite a few more if you want to. That offer still stands, 5 points of extra credit. All right, Ian. Oh, Ian, you get a fun one.
Hello?
Hi, Ian. How are you doing?
Oh, pretty good. Yeah, I'm having a little trouble, obviously, with the mic, but I'm doing my best on the phone.
That's all right. We had switched to the beginning too, so.
Yeah. Okay. You want me to start? Okay. You invest 10,000 in the security. So, what is you have to figure out the rate of return. So you have to find I over Y, right?
Mm-hmm.
So I can't. Well, I have to close this. Okay, good. All right. So what you have to do is 10 years. So it's going to be N, and it's just annual. They haven't talked about any compounding differences. Then PV is going to be minus 10,000 because your initial investment is 10,000.
Mm-hmm.
And then you're talking about doubling, so it's going to be 20,000 of fair value positive, and then 0 PMT.
And real quick, why was the 10,000 negative?
Huh?
Why was the 10,000 negative?
That's because that's the initial investment, and you're basically putting money, you're taking money out of your bank account into an investment. So it's basically just you're not taking money in basically, because that's you're investing.
Perfect. And I always think about my pocket because it's kind of hard with accounts because you have pluses and minuses, but I just think about it's possible for me to spend.
Okay. And then I have to calculate it 1 second. I got 7.18 as
Yes.
my IVY.
7.18, perfect. Now, real quick on this, what would you normally round to? So we have 7.1773.
I mean, do you want to do it to, I guess, at least 3 or 4 decimal places, or do you want just 1 decimal point? It depends.
I guess this is really a question for us. We like 2 decimals.
2 decimals?
Mm-hmm. So different
Okay,
classes have different things, but yeah, for us, it's fine to put 2 decimals. If you're in a finance class, they're probably going to want you to put 4, but there's really no need to go that specific.
Okay. So 2 decimals, perfect.
Awesome. Thank you, Anna. Does anyone have any questions? You did a great job. If somebody else wants to raise their hand, I can give them another one. If you want to let us know if you have questions, then we can address those. Oh, this is an interesting problem. What's weird about that interest rate? It seems really, really small, right? An interest rate of 0.05. Do you think that was a typo? Was that actually supposed to be 5%? No one has an opinion about this interest rate? All right. So this interest rate is actually extremely realistic if you have your money invested in a savings account at your local bank or credit union. Just to kind of give you an idea, some of the investments we've been talking about, we've been looking at interest rates at 3, 5, 8%. Those are pretty typical investments. We'll get into this more later, but for a lot of investment vehicles, those are pretty typical percents. But if you were to put your money in a generic savings account, it would be this low. So.
Hi, can you all hear me?
Yeah, we can hear you great.
Okay, great. So N will be 4 years before. Do I need to write that in or not?
Okay, wait, can you say that one more time?
N is 4.
Okay.
Pi over y is 0.05. The present value is negative 1,000. We're solving for the payment. And the future value is 3,000.
Sorry, what was the future value is?
It's 3,000.
Okay.
I'm not so great at the calculator. I can plug it in.
All right. So we have 4n.05 for interest, 1,000 negative for present value, 3,000 for future value, and computer payment. So about $500, $499.13. So let's do a quick sanity check here. So we want to save monthly to go to Canada. So we need to save $500 a month. Sure to adjust N, I, and payment. We're solving for payment, so it's already going to be adjusted, but we do need to adjust our N and our I. So for N, what are we going to do to adjust that per month?
It's going to be 4 times 12.
Times 12, okay.
So I guess we can go back in and put 4 times 12 and
okay.
And then 0. I'm sorry. 5. So do you put 48 in?
Yep. So yep, I have N is 48.
And then 0.5. It says divide by 1.
Divided by 12.
Oh.
Yeah. So we're going to 0.05 divided by 12. And this one's extremely important that you don't round this to 2 decimals before plugging it into your calculator.
Oh. Okay.
That's going to go into your interest rate. Okay, now are we done? Now we can solve?
Now we're not done.
Alright. So now we can do compute payment, and we come up with $41.58.
Yep. That's correct.
Alright, does that look a little bit more reasonable? Let's do a quick sanity check here. We are saving monthly for 4 years. We want $3,000 at the end of it. So if we take 41.58, we're going to save that monthly, so times 12. So each year we'll be saving around $500. And then multiply that by 4 years, which is how long we're saving. We're going to have right about $2,000 when we graduate. So that remaining amount is from interest. So if we calculated this, we had an initial $1,000 as well. So if we add back in that 1,000, there we go, okay. So that remaining amount is going to be our interest rate. Notice how that's really, really tiny, right?
Mm-hmm.
Notice how our interest rate is really, 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 really tiny, right?
Mm-hmm.
So we know that we did it right. So that's where the sanity checks come in. I have a tiny, tiny interest rate. So when I calculate it out, I'm super, super close because I had a tiny interest rate. Now, say our interest rate had been 5%, so if we'd done 5 divided by 12, plug that one in for our interest rate. Now, real quick, I didn't clear my work. I'm just changing one key, so it's okay to type it in and then hit that for interest rate. It's going to keep the rest of it. So now I can hit compute and payment. So if I had 5%, then it would come up with $33 instead of $41. Cost times 12 times 4 years. So 1,000. So you see how there we would have a significantly larger difference with a significantly larger rate. Like that point across, the interest rate has a huge impact on the amount of money that you actually have to save to be able to reach your goals. And we'll talk about this a lot more later, so don't worry too much about that right now. But in Unit 6, we start talking about different investment vehicles, and this becomes a big deal. Just so you guys are warned in advance, time value of money is going to continue to be a topic in this class pretty much the entire semester. There's a couple of units that we're not going to use it with, but it is going to show up again and again. So this is a topic you really, really want to understand now. Thank you. Great job. So we do have some other ones. Let's actually table those. Your first project, you're actually only going to solve for 4 keys at a time. In Unit 3 is when we're really going to start getting into more of these ones where you're using every single key. So right now I'm kind of trying to show you some of the basics. We will do a little bit more with that when we get a little closer. I think it'll make a little more sense. Okay, so Matt is wanting to give it a try. Matt, did you want to try this problem? Are you able to call in on your phone, or do you have a mic set up? Everyone else, make sure to go ahead and work on this problem so that you can double check your answers.
Hello, can you hear me?
Yes. Hi, Matt. How are you doing today?
Good. How are you doing?
Good. All right.
Okay.
Walk us
All right. I'll give this my best shot. So I apologize for any mistakes in advance. Okay. The lump sum of $10,000 into the investment account by annual interest rate of 3% compounded monthly. How much will you have after 15 years? So I'm assuming it wants the future value. That's what we're trying to figure out.
Yeah, so we want to know how much we'll have after 15 years, so we're solving for future value.
Okay, so payment should be 0. There's just, compounding interest. Principal value is the initial investment of $10,000, so that would be negative $10,000. Interest rate would be 3% divided by 12 because it's monthly.
Perfect.
So do my calculator real quick and I can figure out what that is. 0.25. And N would be 15 if it's 15 years. And this is where I'm having problems because I can't seem to get the values to set on my calculator. But I'll go ahead and give this a try.
Okay, so I set it up just the way that you told me. Do you want me to go ahead and solve for future value, or do you want to fix an error first?
Is that not what I'm supposed to be solving for? I thought it was. Just to figure out the amount after 15 years. I thought it was the future value amount.
So is N 15 years? 15 years.
Yeah, 15 times 12.
Perfect.
So,
All right, so now we're ready to solve. So student can always go back and double check NI payment. They all have to be in the same term. So we can compute our future value. And is everybody getting the same number? Awesome. Great job, Eric. Thank you. Eric's talking on mine. Matt. Thank
No, that's
you.
fine. They helped too. I appreciate that. Thank you, guys.
Oh, I hope it helped you too. All right, thank you everybody for joining us today. We do have to get going. I definitely enjoyed this. I hope you did as well. Let us know in your online classrooms if you have any questions, comments, concerns about this, if you liked it, if you didn't, if there are things that we can improve on. And we are happy to schedule more of these if they are helpful for you guys. So thank you so much for joining us, everyone.
Yeah, thank you. So any other questions, guys? All right, thank you, guys. Just let me know if you have any questions. Post your questions on the discussion boards.
Yeah, I think each teacher should have a link where they want you to post it.
All right,
Thank you. Have a great day.